The Best of Our Knowledge explores topics on learning, education, and research. I'm Madeline Reynolds, in for Lucas Willard. Coming up, vampire bats. Not really an inviting name, but new research discovers that these bats have behaviors of cuddling, playing, and more. And we also learn about an ancient Voyage recreation that happened thousands of years ago across one of the strongest ocean currents in the world by a team of researchers. You're listening to The Best of Our Knowledge. I'm Madeline Reynolds. I want to suck your blood. Does that come to mind when you hear the words vampire bats? Well, actually, what if I told you this is fiction? They do not suck blood, but rather lap it up when eating. Researchers have discovered these often perceived scary species of bats are actually quite cute. The formal name for the species is spectral bats. Researchers have discovered for the first time ever behaviors that show hugging, playing, sharing, and more. So not as scary as everyone often makes them out to be. To learn more about these behaviors, I spoke with Marisa Tika, a research associate at the Natural History Museum in Berlin and a PhD student at Humboldt University. Please note there are a few places in the interview where the audio glitches.
So they're the biggest bat species in the whole Americas, and with a wingspan of up to 1 meter. And they have a striking appearance. So they're darkish brown, sometimes even a bit reddish from the fur. They have large ears and also prominent snout, and then also a nose leaf for echolocation, so for orientation. And unlike many other bat species, these bats, they're carnivorous. So that means they mainly feed off birds, but also small mammals like rodents. And then also they are monogamous. So that means they live in small family groups consisting of a female and a male and its offspring, which is very special and not often seen in the bat world. And they can be found in diverse tropical ecosystems, so in a tropical rainforest, but then also in tropical dry forest. And they range from southern Mexico across Central America to the northern part of South America. And they usually live in hollow tree cavities. And like I said, it's a very rare species, so they're not often found. So we're always very lucky if you see the species as a bat researcher. But sadly, we see a declining population trend, so reflecting its rarity despite this kind of widespread range.
So I would love to know more about kind of like the hunting practices of this bat and kind of what they consume, what they eat, what their prey are.
Mhm. Mainly birds, which can be the size of a dove, but then also other small mammals like rodents, so rats and mice, and then basically anything that they can find, and sometimes even other bat species. And we don't know so much yet about like their hunting strategies, but we know that there's this diversity of prey, and so probably the species employs a variety of hunting techniques. For example, with the rodents, then they're very likely to be captured near the ground, given their terrestrial habits and their mobility. Whereas then many bird species that they consume, they're nocturnally inactive, so they're probably taking directly from their nests during sleep. And then interestingly, several of these bird species that they prey upon, they're known to emit like a strong odor, which led us to think that maybe olfaction may also play a role in prey detection, but there's only just this anecdotal evidence for that. It's not proven yet. And then with the other bat species that they might eat, it's assumed that they caught in flight, so mid-air, requiring highly agile and precise aerial hunting, which is very fascinating, I think. And in general, they're very powerful and agile flyers.
So how did you discover the bats and collect the data needed to carry out your research with your team?
So part of my work is just going through the forest and look for new bat colonies, and then just poking my head into the like hollow trees and see if there are any new bed roosts and hoping there are no snakes falling down on me. And yeah, this is also how this happened, how I discovered this colony. I just went around the forest and I saw this potential tree and I went up to the tree and I was like very fascinated from the first second because it's a very popular bat species. So I think most bat researchers would recognize this bat like from a distance. So I immediately knew, okay, this is the speckled bat. And I was so happy and very fascinated, and I knew I want to do research with these bats.
So, what was discovered is that they kind of like to huddle together. And I think in the research, it outlined it and called it snuggling. And then they also like playing with, bugs and insects. So that was the most fascinating thing to me. It's almost cute, right? It's cute. You're like, wow,
Mhm.
it's really sweet. So can you just kind of talk about those behaviors more? And we know it's not their only social behavior is snuggling and playing with, their food, quote unquote. But you also share that there was something called prey sharing behavior.
Yes. So the cuddly behavior we called social roosting behavior. It happened during the day, but then also at various points during the night. And then usually one of the bats, one of the adults would wrap its wings around all the others, and they would frequently groom each other and then also emit vocalizations and just stay in this position for a longer time, sometimes even sleep, but mainly just rest together. And then also with the play behaviors, we saw three different types of play behavior. First one was the object play behavior, where we could see some just playing around with our cameras inside of the roost that we installed. And it was really fascinating to see because they could have really scratched and destroyed the cameras because they're so powerful, they're so strong, but they didn't do it. So they were super gentle with our cameras. I mean, it was a foreign object for them, but they approached it, they sniffed around, and sometimes even like turned my camera angles. But I mean, they didn't really, there was no single scratch on my cameras, which was really fascinating. Another play behavior, very often we could see that the one of the sub-adults is just sitting inside the roost, often at the very beginning of the night when still all the bats were inside of the roost, and then just started chasing cockroaches in the roost. And we defined this as play behavior because not once did actually eat the bat the cockroach. It was just like chasing the cockroaches for a bit, but then after a while, then turn around and maybe got bored. But that was a behavior that we saw quite frequently in all of the sub-adults. And then another play behavior we saw is a social play between two sub-adults. You could imagine this kind of like a sibling play. So you can really see on the videos, they play around and kind of poke each other with their wings, but it's never really aggressive. It's like a sibling fight, as you would imagine. So it's very playful. And then sometimes when a bat from the outside would enter the roost and then join the others in the main roosting spot, the others would then approach the incoming bat and then kind of wrap its wings around the incoming bat, kind of like a hug. Just for a second or maybe two, they didn't stay in this position. It was more like a welcoming, and then they like went back to their original positions. With the prey provisioning behavior, this is probably the most fascinating behaviors for me, and maybe for most people that we saw, is that really bats bring in prey items into the roost and then transfer this item to another family member. And first we called it prey sharing, but then we realized it's not actually sharing because they don't like do like half half, but no, it's like a whole transfer of the prey. So it's more like a provision of food. And we saw this from usually from adults to their offspring. In some instances, just a few, we also saw it in certain contexts also that a male would bring in a prey item and then share it with the lactating female who was guarding the pup and couldn't fly out in the night.
So we now know these bats are quite intelligent. They have, complex behaviors. It's not just like you just told us they do a lot of cool, interesting things with each other. What does these behaviors reveal about this species and maybe other bats?
Our findings offer a compelling example of cooperative behaviors in bats. So it's not just very limited or simplistic, as maybe many people thought before, but these behaviors, like the food provisioning, this appears to be something like a method of teaching the offspring prey handling skills. And then just in general, we saw like a lot of cooperative behaviors, and this suggests that this might be very important in the species for the offspring survival, but then also for reinforcing these family bonds that promoting the long-term success of the offspring until they're fully independent and leave their family, their natal roost.
So, what are some misconceptions of this species of bat? Not knowing they are actually very complex creatures and exhibit all these different types of behaviors.
Probably to most people, on the first look, these bat species in particular might look very intimidating. They have really sharp teeth and powerful jaw, and they apex predators. But then in reality, they're very gentle, not just with each other, but then also with the unfamiliar objects like the cameras that I installed in the roost. And like I said, they could have easily damaged equipment, but they never did it. And I never saw any kind of aggression between these animals in the family group. I mean, like the play fighting, but that's it. Even with the prey transfer, you would think maybe this could rise any conflicts. Because there's then prey in the roost, and then maybe suddenly all the bats will just go for the prey item because they want to feed on it. Who is the recipient? They kind of got the context instantly, and then only the bat who was the recipient of the prey item approached the incoming bats, and then the others remained calm in the main roosting spot. So they're very calm, highly social, and surprisingly tolerant.
So, in your research, you also revealed that these spectral bats can offer clues to the health of Latin American forests, which I found very fascinating. So, can you explain how that works and how it can help both the environment as well as even the bats?
So bats in general play a vital role in ecosystems, so from controlling insect populations to dispersing seeds and pollinating plants. And I think just broadly gaining insights into their social behavior helps us recognize that these bats are complex, they're intelligent animals rather than viewing them as a pest. And then, especially with these bat species, the spectral bats, because they require a wide variety of prey, and then very large, mature trees with natural cavities for roosting, their presence can serve as an indicator for forest health. So, finding the species in a given area often suggests that the ecosystem is still relatively intact and functionally diverse. And then protecting this species, therefore, also goes hand in hand with preserving and restoring forest habitats, then also affecting other species in the positive way, especially through the conservation of large trees and restoration of forest fragments with potential cavity formations. So this strategy not only benefits the spectral bats, but then also support broader biodiversity and ecosystem resilience.
Wow. And what do you find the most fascinating about this? All the bats and your research. What is just the most fascinating or surprising to you about it all?
I think there are many aspects, and probably one of my co-authors, they would tell you like other aspects. Probably for me, one of the most fascinating things is that they don't just bring prey back to the roost, but they do this in this very specific context. So, in the context seem to be immediately understood by the other bats. So, like I said, sometimes the male would bring back a prey item into the roost to offer this to his offspring to help it so it can learn how to handle prey and support the transition from milk to meat. And then in other cases, a male might bring food back to aid in the nutrition for a lactating female. But then also occasionally in some situations, especially when the night is almost over and the sun is about to go up. They can also bring it back to the roost and then simply eat it themselves. And what really struck me is how the intended recipient always seemed clear. So there was no fight, nothing, and this was definitely a aha moment for me.
Marisa Tika is a research associate at the Natural History Museum in Berlin and a PhD student at Humboldt University. Her latest research into vampire bats was published in the journal PLOS ONE. You're listening to The Best of Our Knowledge. I'm Madeline Reynolds. Paleolithic peoples made a voyage over 30,000 years ago on a canoe across one of the strongest ocean currents, the Kuroshio Current. This voyage was from Taiwan to Japanese islands like Okinawa. Researchers were, of course, interested in understanding how ancient peoples can make a trek like this without the modern technology we have at our disposal. So to do just that, a team of researchers in Japan decided to recreate this voyage with methods and vessels of the Paleolithic time period. To learn more, I spoke with Yusuke Kaifu, an anthropologist at the University of Tokyo.
The modern humans, also called Homo sapiens, originated in Africa and dispersed all over the world after about 50,000 years ago. As a part of this great dispersal, groups of people went out to the sea to colonize the islands of East Asia. One of those routes from the Taiwan to the southwestern Japanese islands, including Okinawa. Our project focused on one of such events.
So, what was the catalyst in question that made you interested in this specific ancient migration pattern, meaning from Taiwan to these southern Japanese islands like Okinawa?
I was involved in archaeological excavation in Okinawa, and I began to wonder why and how people reached these isolated islands. But stone tools and other archaeological remains doesn't answer this question. So I decided to experience it because it's otherwise we cannot know how difficult it is and what is the challenge involved in those ancient journey.
So, is this specific migration particularly difficult and dangerous, meaning that you have experienced it?
Oh yeah. Okay. So if you want to travel from Taiwan to Yonaguni Island, our destination, the island remains invisible for more than first half of your journey because it's below the horizon. And also there's a strong Kuroshio current, which is one of the world's strongest current. And the speed of the Kuroshio is about 1 to 2 meters per second. So the 1 meter per second is people's walking speed. So you can imagine how fast it is. So it's really strong ocean current. And so you have to cross that current. So it is obviously it's difficult. But unless you experience it, you really do not know how really it is, how hard it really is.
So, just how did you conduct your study with your team?
Mm-hmm. Yeah, I built a big project team, which consisting of scientists from different fields and also specialists, including paddlers and carpenters. Those specialists are important for us because researchers cannot paddle the boat, and we are not good at using the axis, and so we needed them. And then also, the project was supported by the crowdfunding and other donation. This was an open science project, so all our activities were recorded, and everyone can now see it as a documentary film on YouTube now.
So, you and your team, replicated this migration from Taiwan to Okinawa. You used methods that maybe ancient humans would have to create that vessel, that boat, to cross that portion of the ocean. So I'm wondering if you could just speak a little bit more about how you created this boat, this canoe, this vessel to then use. Yeah.
Yeah, one of the biggest question is that we do not know exactly what type of watercraft they used because we don't have any direct evidence from archaeological sites. Those boats are made by the vegetable, so it's perishable. But we can restrict at least the possibility, we can choose the candidates in terms of the local availability of raw materials. Archaeologists in our team made a replica of non-Paleolithic stone tools, and we cut down a large tree using that tool. It took 6 days, but we could make it anyway. And then we could make sure that this tool can produce a canoe. Then we went to the Taiwan to make a realistic model for our voyage. I found that if you go to the top of the mountain, coastal mountain of Taiwan, actually you can find the island far away on the horizon. But the problem is that if you go down to the coast, it becomes invisible because the Earth is round. I don't think that those Paleolithic people found that the Earth is round at that time. But anyway, so you know the place, but it's invisible on your journey. So you have to find that island. And also, as I said, that there's a strong ocean current, Kuroshio, which is flowing north. So you have to find a suitable departure place somewhere in the south. And you have to paddle southward, not directly to the island, to counter to the Kuroshio current. So there's a number of difficulties, but somehow got there already. Paleolithic people on those islands about 30,000 years ago.
So I'm glad that are talking about that, because one of my questions is, do you think that this migration was accidental, or was it, do you think, deliberate navigation? And what do you believe?
We investigated that issue previously. We examined freely drifting buoys on the ocean. Oceanographers are using those buoys to monitor the sea surface condition like water temperature and the salinity. And they use a satellite tracking system to send every data to the land. And so they are monitoring the world. So we made up the idea that we can use that trajectory of buoys. So we examined the trajectory of those buoys from Taiwan, and then we found that most of them do not reach islands of Okinawa. So accidental drifting hypothesis is extremely difficult hypothesis.
I see. So I am curious, though, about your experience along that actual being on that boat, doing that actual migration pattern. How was that like? And did you face any issues along the way?
Oh, yeah. It's a long story. And it was not, we reached the island after 45 hours of paddling. But Voyage didn't go as we expected or predicted. So on the Crucio, the sea surface became choppy, and then paddlers could not rest. And also during the night, it became cloudy, so we couldn't see stars. We trained a lot of us. We have to see the stars to navigate in the night, but it was not visible. But you have to get through it. So we cannot control the nature, and that's the way. But important thing is that through those conditions, our remote ancestors reached those islands. So that's what we wanted to experience.
Wow. And you found that a return journey from, the Japanese islands, Okinawa, was not possible. Why is that?
Because the Kuroshio is so strong. Actually, Kuroshio current is slightly faster than our Dagat canoe. So it's really impossible. If you have a map of that area, and also if you know the flow passage of the Kuroshio, you may be able to make a plan to escape from Kuroshio and return home. But it's much later. We are talking about the first people who go to that sea. So of course they don't have a map and those information.
Would a return journey be possible though in that future? Like, I know we can do that now, but back then, 30,000 years ago, was there a possibility in their near future that they could have done that?
I think the paddling boat is difficult, but if you have sailing technology, it may be. Because, with the sailing technology, people went to Hawaii and East Island, so it should be possible.
Does this study and this replication of this migration from Taiwan to Okinawa answer anything about the ancient humans from back then and maybe their behavior, their strength, and things of that nature?
Oh, yeah. People tend to look down Paleolithic people because their technology is primitive or rudimentary. But we now think, after those experiencing this voyage, we realize that they did something extraordinary with that simple technology. I think that's a great thing. Of course, they didn't have a GPS and smartphone and those modern tools, but they reached those islands. So it's just amazing. But another discovery was we ourselves, because our paddlers, after the training, they also did it. So we can actually do it without those modern technology. Our sense and the power of humans is great. That's our new discovery.
And then my last question to you is, what would you like to research and study into, maybe regarding this topic or similar topics? What are you excited to do next?
Oh, yeah. People ask me, what is your next adventure? But probably I will not do this again because I'm usually studying the fossilized bones of bones and teeth of Homo erectus, Homo floresiensis, and so on to uncover our evolutionary past. So now I have to return to my own field. So there's an interesting project going on in Indonesia, Taiwan, Japan, and so it's exciting.
Yusuke Kaifu is an anthropologist at the University of Tokyo. His latest research into the ancient voyage was published in the journal Science Advances. If you'd like to tell the best of our knowledge what you think, send us an email at knowledge@wamc.org. You can listen to the best of our knowledge anytime as a podcast, downloadable wherever you get your podcasts. If you want to catch up on past episodes or hear more WAMC National Productions programs on the news, academic study, books, women's issues, the media, and the environment, visit WAMCpodcasts.org. This has been The Best of Our Knowledge, episode 1825. The Best of Our Knowledge is a national production of WAMC Northeast Public Radio. Thanks to Lucas Willard. The latest on all National Productions programs is available via the Airwaves newsletter and our flagship station's website, WAMC.org. Until next time, I'm Madeline Reynolds.